Okay, number 1. A rectangle is a 5 by 9, so what's the area? Just give me the number there, so 5 times 9, so 45 centimeters squared. Using a scale factor of 2, what is the new rectangle? What's the dimensions? If you use a scale factor of 2, what's your rectangle going to be now? So this is my new rectangle. It's now a 10 by 18, right? I doubled. So now, what's the new area? So 10 times 18, we can do that one in our head, right? Just add a 0, so 180 centimeters squared is the new area. So what do you notice about how the areas are different? So the area of the second one compared to the area of the first one, so I'm going to say it like this: the area of the new divided by the area of the original. And so if I divide that, I get 4. So the sides doubled, the area is 4 times greater. So can we write a rule? Okay, the area scale factor equals the linear scale factor squared. So the linear would be like when I'm changing just the sides. So if I change the sides by 2, 2 squared means the area is 4 times bigger. Okay, you ready? Number 2. Okay, we had a computer screen and then we projected it onto a whiteboard. Okay, so let's get the area of the computer screen. Okay, so what's the computer area? So 35 times 55. Okay, so now I'm going to do what I did last time. I'm going to compare the two areas with each other. Okay, so the area of the projector compared to the area of the computer. How many times, either larger or smaller? Like, what's the scale factor of the areas? Okay, so the area of the projector is 3.76 times bigger. So now here's the next step. I'm going to square root that because that's how the area changed, but I want to know how does the sides change. So that conversion is a square root. So that button is just on your calculator, not the other one. So square root of 1.94. Okay, so if the area changed by 3.76, the sides are changing by 1.94 times. So what are the new dimensions of this computer screen? So 35 times 1.94 . So that's the one side of the computer. So the side lengths are changing, so please do the same thing with 55. It's going to be 1.94 times bigger. Okay, number 3 here, we have a cube. So this is what a cube is, just that shape I drew before. A cube is 8 by 8 by 8. So what's the volume of that shape? So you're just going to go 8 times 8 times 8. So the volume is 512 centimeters cubed. That's how you do a volume. Okay, next. Using a scale factor of 1/2, find the new dimensions. Okay, so at each side you have to times by 1/2. So the 8 is now going to be 4. So 1/2 means I shrunk it, right? A scale factor of 1/2 means something's going to get smaller. So what's the volume of this new cube? So 4 times 4 times 4. Okay, so the volume of the new one compared to the volume of the first one, the volume new divided by volume original. So what do those numbers divide to? 0.125. So that is what the scale factor is between the volumes. So where did that come from? Can you try this in your calculator? Brackets. What is 1/2 cubed? So brackets 1/2. What is 1/2 exponent 3? What's 1/2 cubed? Did you get 0.125? Which is 1/8. Okay, so if we want to write a rule, the volume scale factor equals the linear scale factor cubed. Okay? So area changes according to the sides squaring, and volume changes according to the sides cubing. Okay, next one. If we have a square and it's got a 6 length, and then we need to enlarge it, and we need to enlarge it in a way that it turns into a 15. Okay, so what is the scale factor of the sides? So I'm going to take this new divided by the original. Okay, that's kind of my method, new divided by original. So that's 2.5 times greater. Okay, so if the sides are 2.5 times greater, how much bigger is the area going to be? So what do I do with the sides? So 2.5 times bigger, but I'm going to square that number, right? So squaring that number. So the area of this will be 6.25 times bigger than the area of that. Okay, so I just took the scale factor and I squared it. Okay, this doesn't really make sense on a square because a square is not a volume. So I'll just pretend now that we're doing a cube. So if this was not just a square, but if it was a cube, what would the volume change by? So what are you going to do? You're going to take the side scale factor and cube it. So the volume is going to be just over 15 times larger. Okay, I'm kind of looking at the last example, and it's the exact, oh no, it's not the exact same. Okay, we'll do it. Okay, we have an object with a volume, and then it's enlarged by a scale factor of 120 times. Okay, how many times larger is the area? How many times larger is the volume? So the area will be 120 squared times bigger. So 14,400 times larger. The volume is going to be 120 cubed times bigger. So a big number, 1 million. So I didn't ask this, but what is the new volume then? So how am I going to get the new volume? So this was the original volume, and I'm going to times it by, that, okay, because that's how much the volume changes by. So that would be the new volume, okay, because it increases not just 120 times, but it increases 120 cubed times.